catalyst, when we carried out the hydrogenation in the presence of platinum, nickel, or ruthenium catalyst, alkyne convert into alkene as an intermediate in first step, as an intermediate. Then further hydrogenation takes place because this alkene act as intermediate that is not stable. So it convert into, through further hydrogenation, through partial hydrogenation, lead to the formation of alkane, right? So what actually we want to stop this reaction in alkene stage. How we will stop this reaction in alkene stage? So this is the question. So the simple phenomena is alkyne could be used to prepare alkenes, right? Alkynes could be used to prepare alkenes if a catalyst were available that is active enough to catalyze the hydrogenation of alkyne to alkene, but not active enough for hydrogenation of alkene further, right? So therefore Lindlar catalyst, one of the catalysts, Lindlar catalyst in quinoline, quinoline act as sequential. So Lindlar catalyst where we are using palladium on BSO4 and a quinoline, right? So in which alkyne convert into alkene through hydrogenation, through controlled hydrogenation, we get alkene. It cannot further convert into alkane, right? In the presence of palladium on BSO4 in quinoline, or either we use palladium on BSO4 or palladium with quinoline or charcoal, right? So alkyne convert into alkene and not alkane. So this is called control hydrogenation या control reduction कहते हैं इसको. One of the example is this is a compound. If we just use Lindlar catalyst, Lindlar palladium, that is palladium on BSO4 or palladium on charcoal, we get alkene, right? We get alkene. We just reduce this alkyne into alkene as alkene, right? If we will discuss further examples, you can see here there is alkyne in which control reduction lead to the formation of Cis-Alkene. If we use palladium with charcoal, C for charcoal, right? Reduction or hydrogenation of alkyne with palladium and palladium with charcoal lead to the formation of Cis-Alkene. What do you mean by cis? This is a geometrical system in which both hydrogen on same side. This is called a cis, right? But when alkyne react with sodium in liquid ammonia, again we get alkene. But in this stage here, sorry, it is wrong. It looks like cis, but it should be trans. Right, hydrogen should be here. Hydrogen should be here. So we get trans-alkene. This looks like cis-alkene, but actually, when hydrogenation carried out in sodium in liquid ammonia, we get trans-alkene. But when alkyne treated with hydrogen in palladium in charcoal, we get cis-alkene. Again, this is ethine. Ethine, hydrogenation of ethine in palladium in charcoal lead to the formation of ethene. Similarly, propine when treated with hydrogen in the presence of palladium with charcoal lead to the formation of propene. So this is called control reduction, right? Control reduction. We can get alkene from alkynes, different alkene from alkyne. Otherwise, if we not use this palladium in charcoal, we get, what will happen? This alkene further hydrogenated lead to the formation of alkane. Any question? Any question?
Sir,